from like 5th or 6th grade, but like let's just focus on the factor part. Do y'all remember what factors are?
Yes.
What? Yeah, the two numbers that multiply together to create whatever that number is. So we're gonna kind of skip around. If you look at number 2, what are the factors of 30?
3 and 10.
3 and 10, 5 and 6, 1 and 30. Do y'all remember did y'all ever have to do the T-chart?
Yeah.
Like 1 and 30, 2 and 15, 3 and 10, 5 and 6. Did y'all ever do that? Oh, so you just listed them? Okay. I like making that table or that T-chart. You'll see why. We have to find factors for our next set of stuff for today that we're doing. We're going to go to number 1. We're going to skip because we're going to skip down to just finding a GCF. Does anyone remember how to do that part? Okay. To find the GCF, what are the factors of 39? So numbers that multiply to give you 39. 1 and 39, 3 and 13. Anything else? 13 and 3, but you don't have to list repeats. Factors of 6, 1 and 6, 2 and 3. What's the greatest common factor? 3. So who remembers what greatest common factor means now?
I still don't know.
Literally exactly as it sounds. What is the biggest number, the biggest factor they both have in their list? What is the biggest thing they both have in common? Okay, then that's the greatest common factor. It is possible to have a greatest common factor of just 1. Like if I gave you the numbers 3 and 7. 1. They're both prime, so that's not even going to work. It is possible to have a greatest common factor of 1. If you look at number 2, numbers that multiply to give you 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Numbers that multiply to give you 28. 1 and 28, 2 and 14. Does 3 work? 4 and 7. So what's the greatest common factor? 4. Okay. This all kind of coming back to you a little bit. You list out your factors. What's the biggest number? Maybe you got good and could figure things out in your head every once in a while. Okay. Let's look at number 3. What's different on that problem now? Yes, we're throwing in the algebra version. Greatest common factor, not just with numbers, but when there's also letters involved. So, 39. Well, we already did a list for 39. That's over here. Why not? Why just rewrite it? We're good. And we already did a list for 30. That's right here. What's the greatest common factor between those two? 3. Okay, so 3 is the number part. When it comes to greatest common factors letters, well, what letters do they have in common? V. They both have a V, so that's our greatest common factor. 3V.
Wow. That's going to get harder.
Okay. Who's good with their greatest common factors? Who can look at number 4 and raise their hand and tell me what that greatest common factor is? Yes, ma'am. 7. That is correct. 7 is the number.
How big is your house?
Now, when it comes to the letters, this first one would be M and then N squared, so N to the power of N. This one would be N squared and N. So back to that expanding part. What do they have in common?
N.
How many N's do they share? Do they both have? Just 1. So 1 N down here. And then, is that the only thing they have in common? They also have 1 N in common, so that's part of our common. Okay. Raise your hand. Who's got the greatest common factor for the number for number 5? Good job raising your hand, guys. Thank you. Good, that's right. Okay, 10 is correct. That first term has y cubed. The second one is y squared. So what do they share? They both have this. meaning y squared. Okay? This time raise your hand. What is the greatest common factor of number 6? 12 is not right. 48. 96 is 48 times 2. 144 is 48 times 4. So 48 is our greatest common factor. Now when it comes to letters, this has x, 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 and a y. This is x, x, and a y. And then this is x, x. So what do they have in common? They both have x. All three of them have x squared. Do they all have y? Then that can't be listed. This is our greatest common factor. We feel okay with that? So what we're going to be doing, we are about to start not just greatest common factor, we are going to start factoring things. Factoring means undoing multiplication. So it's kind of like division, except we don't know what we're dividing by. We have to find what we're dividing by. So we're going to be taking out, we're factoring out, factoring means we're undoing that multiplication part, we're taking some stuff out, we're separating it. We're factoring out the GCF of our polynomials. Meaning, look at number 7. We have 3 terms. Is there something, all 3 of them, what's the greatest common factor of all 3 of those numbers? 5. We are undoing multiplication. So it's like we're undoing distributed property. So we need to figure out what will be left over. Those are going to be in parentheses. Well, to figure out what's left, divide it all by 5. What's 15x squared divided by 5? 3x squared. 20 divided by 5. So plus 4x. And then negative 30 divided by 5. And that's our answer. Our answer is going to look like maybe you feel like you're doing something wrong, like you have to redistribute or do something. No, we are undoing distributing. That is what factoring is. We're undoing multiplication. So if we look at number 8, they have 5 in common. They also all have k in common. So we can take out 5k. So to figure out what's left, divide everything by 5k, and that's what's remaining inside of the parentheses. So 5k cubed divided by 5k. Well, 5 divided by 5 is 1. K cubed divided by k, k squared. What's the next term going to be?
K.
Just plus k. And then what's the last term going to be? Minus 3.
We did it.
You feel like y'all can try for your own? Maybe? Okay. I want you to do number 9, 10, 11, and 12. Okay? For number 10, 12 on the outside, and then m squared minus 4m plus 3. We're going to skip number 11 for just a minute. Number 12, 2 on the outside, and then 3c squared minus 9c plus 1. Okay. There's a reason I skipped number 11. On number 11, you have those general things set up.
Yes.
Okay. On this one, I would have taken out the negative as well.
Okay.
And there's a reason. Okay.
What's your mind?
On this one,
On number 13, what's the number that you both have in common?
1. Oh, number 13.
Number 13. 8. Right. And they both have a y in common? I would take out the negative on this one too.
But why does?
This is not in paper. I'm writing it.
Did we write it too?
Yeah, I was adjusted. I would also, what's the number that all three of these have in common?
3.
Okay. So we're going to take out 3. I would also take out the negative on this one.
So you always take out the negative if it's in front.
Plus x. So what have all three of those had in common? What about the negative though?
You bring it to the outside. Oh, so you flip all the signs.
The very first term. So is it that big of a deal for this? No, not really. But kind of. When we start factoring, we will need to make that change. Anytime that leading term is negative, that factors out as well. A negative will also factor out. Only when that very first term, when that leading one is negative. I don't care if that middle one's negative. I don't care if the last term is negative. It's that leading one that I don't want to be negative. Especially we're going to start factoring, which is even more undoing of the distributing. So that is something just to kind of keep in mind. We'll have plenty of practice with it. I just want to show it to y'all now. All right. So go to your next page. Your update, which is the one with all the pages on. Okay. Yes, we are going back to Algebra Tiles. We are factoring today. So what I want you to do with your table, enter the entire front page. Okay. Are these what we got for the top part?
Yes.
Okay. Down below, what were the two parentheses?
X plus 4, x minus 3.
And then, so what was it equaling in the
X
middle?
squared plus x minus 12.
Okay. What about the next one? What was
2x minus 3, 3x minus 1, 6x squared minus 11x plus 3.
minus 11x plus 3? Okay. Yes?
Yeah.
Are we good with that? So, what we are doing today, we are factoring. All of our factoring problems, don't touch those tiles yet. This is what we're given. So we're going to be setting up the inside part. So similar to dividing. Except with dividing, I told you what was along the side, correct?
Yes.
And now you know nothing.
Oh.
All you know is what it's going to be. So if we have to go backwards, what shape is it always going to make inside this model? It's always a rectangle, every single time. You have to figure out how it fits, making that nice little rectangle. The other thing, with dividing, we have remainders sometimes. Factoring doesn't have remainders. It doesn't have it. It needs to make a perfect rectangle every single time. If that rectangle is not a perfect little nice thing, then you've messed up with your picture somehow. So I gave y'all algebra tiles. I know normally I'd let y'all kind of play with it for a little bit. We're not going to do it today. Y'all have seen those enough that I think leave them in the bag if you don't like them. Take it out if you know you want to use them. Y'all okay with that? All right. So if we look at number 9, all we're given is this part. We need to figure out what were the two parentheses that made that. What's something we know is going to be set up? Okay. X squared going in this corner. We know that for sure. We need to keep the ones in mind. The ones and the x's are related. Like it depends on how I place my x on the side and on the bottom to create those ones. Anyone have an idea of what we're going to set up? Perfect. I love that. 4 x's along this side. Okay. And then that makes my open spaces for a nice pretty 8 box. Which is wonderful. So once it is set up as that perfect little box, it has everything in there, that means our answers are the top and the side. What would have been up on the top? An x plus 4. And what would have been along the side? Perfect. X plus 2. So this is your actual answer. X plus 4 times x plus 2. So your answer is a set of parentheses when we factor. You are undoing double distributing. You are undoing the multiplication to figure out what were the two polynomials that multiply to give you that. We're going down to number 11. I want you to try it. See if you can do number 11. Now that you've seen one example, see if you can do 11. So there's number 11. Has anyone gotten number 12 yet, or number 10 yet?
No.
Ooh, you got it?
I think I got it.
Okay. Okay. Let's see. X squared. Did you put them like going along the top, or did you do it as a cluster of a 2 by 2? Okay. Because with 4, you could. Those are 2 different options. Both of those options, whether you did it just straight along the top or as a 4 by 4 or 2 by 2, could have worked potentially. Okay. What did you do after that?
And then I put 6 positive x's on the right side.
You can do that, and you can like cancel out your x's.
They were positive.
Yeah, and then I did. Oh, flip that. I mean, those are negative.
There we go. Yep.
Oh, I did them on the bottom. Same thing.
Okay, so you did 6 negative x's.
Oh, it's just that I got it, but I just forgot it.
Okay, but that's negative 6x, and then 2 positives along the bottom. Okay, do our x's now create a space where the 1's fit? Because it is not possible to have these remainders when we're doing that. That's how this is a little bit different than divided. It has to work out perfectly and make that nice perfect rectangle. But then our 3 negatives would be right here. So this is correct. You were right. What would the answers be? What would be along the top?
2x minus 3.
2x minus 3.
2x plus 1.
And then 2x plus 1. Okay. Did anyone figure out, like, those of you that like, got it, has anyone started figuring out, like, a thing to kind of look for as you're setting it up? Yes.
When you look at your one text, what like number, kind of like based on the x's, what times what?
Right. If you look at your ones, you have to think about how you can split your x's into 2 different groups. That's going to create that ones opening. That's that thought process you have to kind of go through as you're drawing it. Raise your hand if you tried number 12 yet. Do you want to try it first, or do you want to do it together?
Yes.
Okay, y'all try it first. Those of you that got it, where do the x's go? How many x's?
3 x's on the top, 1 on the side.
Oh, sorry. 3x.
So what would I put here? Negative x. What would I put?
Negative x.
Do I need any more below here?
Another row.
Okay, another row of x's.
Yes.
Negative x's.
Yes.
And
And then 1 on the
then
side of the, to the right of the x squared.
positive or negative?
Negative. And
Negative.
you get the 2 positives.
And then that's how those 2 positives, because we have negative x's in both parts. So what would the answer be?
3x minus 1, x minus